Okay, learning target 4.e and f, lumping them together here. So it says, let t be any real number and let p of xy be the terminal point on the unit circle, determined by t. Then sine of t, we define as just our y value. Cosine of t is just x. Tangent is y over x. And then the rest are the reciprocals. If sine is y, cosecant is 1 over y. Cosine is x, secant is 1 over x. Tangent is y over x, cotangent is x over y. So if I want to identify trig functions for t, so t is pi over 3. So I want to identify all 6 trig functions for pi over t. So I want to know sine of pi over 3, cosine of pi over 3, tangent of pi over 3, as well as cosecant, secant, and cotangent. So let's think unit circle. So we have our unit circle here. We're thinking about pi over 3. So pi over 3 is right up here. So our point, or the terminal point at pi over 3, is 1/2 root 3 over 2. So that's our x and y value. So that means the sine of pi over 3 would be just the y value, root 3 over 2. The cosine would just be the x value, so 1/2. The tangent would be y over x, so root 3 over 2 over 1/2. So a little work needs to be done here, so let's multiply by the reciprocal of the denominator. So 2 over 1, that'll cancel our denominator. Up top, 2 and 2 cancel, so we have root 3 over 1, or just root 3. Cosecant then is the reciprocal of sine, so that would be 2 over root 3, which we don't like square roots in the denominator, so let's rationalize. So that'll be 2 root 3 over root 3 times root 3 as well, just 3. Secant, so that's the reciprocal, 2 over 1, or just 2. And cotangent would be 1 over root 3, so reciprocal of tangent. So multiply by root 3 over 3, and we get root 3 over 3. So sorry, multiply by root 3 over root 3. Okay. And there we go. So we can use our unit circle to identify these trig functions for these, for any given angle on the unit circle. So let's look at another. So we have pi over 2. So again, we want to find sine of pi over 2, so sine of t, because t is our angle, cosine and tangent, as well as cosecant, secant, and cotangent. So let's figure out what that measure is. So I'll draw the unit circle this time. So with our unit circle, pi over 2, that's that angle there. So that point on the unit circle would be an x value of 0, y value of 1. So x is 0, y is 1. So sine is just our y value, so that's just 1. Cosine is just our x value, so cosine is 0. Tangent is y over x, so 1 over 0. Oof, 1 over 0. What is that? 1 over 0 is undefined. And you'll see that if you take 1 over 0 on a calculator. Error, divided by 0. You can't do it. You can't divide anything by 0, so what we do is we call that undefined. Cosecant, 1 over 1. Just switches to 1 over 1, flips there. Cosine is, you could think of it as 0 over 1, so secant would be 1 over 0, which again is undefined. Cotangent, so if tangent is 1 over 0, cotangent would be 0 over 1, or just 0. All right, so sometimes I might ask you, rather than asking for all 6 trig functions, I might say, well, just give me one. Just give me cosine of 2 pi over 3. So we know cosine refers to the x value of the terminal point. So we'd have to think, where's 2 pi over 3? So you could use your unit circle as a reference. 2 pi over 3, well, that's up here. The x value is -1/2. So cosine of 2 pi over 3 would be just -1/2. Same idea here. Tangent of -pi over 3. Well, as I look at my unit circle, pi over 3 is not the same as -pi over 3. So we don't, remember negative angles, you have to go backwards. So it may be helpful to find a coterminal angle first that is on the unit circle. So remember, to find coterminal angles, we add or subtract multiples of 2 pi. So it's negative, so let's add 2 pi. So we're adding 6 pi over 3 if we write that as common denominators. So -pi plus 6 pi is going to be 5 pi over 3. So 5 pi over 3, that sounds like something on our unit circle. It is. It's right down here. So we want tangent. So tangent is y over x. So at 5 pi over 3, y is -√3 over 2. X is 1/2. So -√3 over 2 over 1/2. So times that by 2 over 1 so that we can get one fraction. And that cancels too. We just have -√3. Next one, sine of 19 pi over 4. That doesn't sound like something on our unit circle. It only goes up to 2 pi. So let's find a coterminal angle. So let's subtract 2 pi, or 8 pi over 4, with a denominator of 4. So that gives me 11 pi over 4. 11 pi, that sounds like something on there. 11 pi over 6, so not there yet. So let's subtract another. Get 3 pi over 4. That feels great. 3 pi over 4 is right here, 135 degrees. We want sine, so that means we want the y value, which is +√2 over 2. Okay. So these we're asking for the same thing that was being asked for here. I just asked for all 6. With these, I'm just asking for one in particular. One in particular. A few more things to consider. So we can find all 6 trig functions if we're only given one, provided we have the quadrant. And the way we're able to do that is by, again, thinking triangles. So here, it says cosine is 3 over 5, and t, so t is our angle, is in quadrant 4. So quadrant 4. So that's over here. So there's t. And it says cosine is 3 over 5. So cosine, remember, ka is adjacent over hypotenuse. So what this means is our adjacent side is 3, our hypotenuse is 5. So if I want to find the other trig values, what I would need is I need to know that y value. Or rather, a better way to maybe think about it would be by thinking about it as cosine is 3 over 5 and our hypotenuse is 1, so that it sticks. Because it could be in a unit circle. It doesn't really matter because we're just talking about an angle, and that may be a little more valuable. So one way we can find y is by using that Pythagorean theorem. So 3 squared is 9 over 25. So if we subtract 9 over 25 from there, we'll have 25 over 25 minus 9 over 25, which is 16 over 25. So take the square root, and we get y equals 4 over 5. So if we're trying to find our other 6 trig functions, sine, remember, is just y. So y is 4 over 5. We already have cosine. That was given to us. It's 3 over 5. Tangent is y over x. So 4 over 5 over 3 over 5. So I need some space here. So 4 over 5 over 3 over 5. So let's simplify by multiplying by the reciprocal, and we get 4 over 3. Then the rest, so we have cosecant goes with sine, and that's just the opposite, so 5 over 4. Cosine goes with secant, again, just the opposite, so 5 over 3. And cotangent goes with tangent, so just the opposite, 3 over 4. Okay. The last things to identify here, and these are things that we've already kind of pursued and talked through, are reciprocal and Pythagorean identities. So reciprocal identities are just relating our trig functions to other trig functions. So, like for example, we've talked about how cosecant is the reciprocal of sine, so we could represent that as 1 over sine. Secant is the reciprocal of cosine, so we could represent that as 1 over cosine. And tangent is the reciprocal of cotangent, so we could write that as 1 over tangent. Similarly, since we know tangent is sine over cosine, we could write cotangent as cosine over sine as well. A couple ways to think through that. The Pythagorean identities are perhaps a little more interesting. We have 3 of them. So we have sine squared plus cosine squared equals 1. Notice you put the squared on the sine and cosine, not on the t, just so that I know this is saying, it's essentially saying I have sine of t times sine of t. Whereas if I put the squared on the outside or on the t, it makes me think I have sine of just that t squared. So this is saying sine times sine, cosine times cosine. So this is our first identity, so I'll box that. And that comes from the Pythagorean theorem. So remember, sine squared is y, or sine is y, cosine is x, equals 1. So this comes from way back in some notes from earlier. Let me see if I can find anything valuable for us. Yeah, so remember with the unit circle, x, y, and 1, so the Pythagorean theorem, x squared plus y squared equals 1. Cosine squared, sine squared equals 1. That's where that comes from. And we have other identities as well. We have 1 plus, wait a minute, what is it? We have 1 plus cotangent squared equals cosecant squared. And then we have a third that is tangent squared plus 1 equals secant squared. You may or may not be able to see where these come from. These both come from this first identity. So what I did to get this first one here was I divided every term by sine squared. So sine squared over sine squared is 1. Cosine squared over sine squared is, oops, so that should be cotangent. Cotangent squared. And 1 over sine squared is cosecant squared. Over here, what I did was I divided every term by cosine squared. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant. All right. And we could use these as well to solve problems like we did up here. That's the last thing I want to talk through. So like if we have here, we know sine of t is 3/5. We could find cosine, or find our x value, by using that Pythagorean identity. So I know sine of t is 3/5, so this is 3/5 squared. So now I can just solve for cosine. So 3 squared is 9 over 25. Subtract 1. You can see we kind of already did this, but subtract 1, subtract 9 over 25, you'll get 16 over 25, take the square root, and you get cosine equals 4/5. The only thing to make note of or to consider is that we are in quadrant 2. So because we're in quadrant 2, x is negative and y is positive. So that means sine should be positive, cosine should be negative, because cosine represents your x value. So actually what we're thinking of is negative 4 over 5. So we have sine of t is 3/5, cosine of t is negative 4/5, tangent of t we can find by using this identity, sine over cosine. So sine is 3/5 over cosine is negative 4/5. So simplify that. So times by negative 5 over 4 to cancel the bottom to 1. Over here we get negative 3/4. And then we can find the rest by using these reciprocal identities. So cosecant is the reciprocal of sine, so that'd be 5 over 3. Secant's the reciprocal of cosine, so that'd be negative 5 over 4. Notice it's not negative reciprocal, so you don't change the sign. And cotangent is the reciprocal of tangent, so negative 4/3. Okay. As I'm looking at this one, I realize I may have failed to acknowledge this quadrant here as we're thinking about this. So in quadrant 4, remember, x has to be positive, y has to be negative for this one here. So this should have been a negative 4/5 for sine, which would change all of these values. So sorry about that. But there we have it.